21. Here we go. So, up to this point, we've only factored polynomials. Yeah, whatever. I will leave this off. We've only factored polynomials higher than degree 2, even though this is a quadratic, where the a value, I won't say the a value, the leading coefficient is 1. All right, it would just be an x squared there. Okay, but now obviously most polynomials have a leading coefficient that is not 1. So we got to figure out how to get the possible factors of those types. Okay, so this quadratic factors the 3x minus 2 and 5x minus 8. What are the zeros of those two, of that function? What makes each bracket 0? What makes this bracket 0? 2/3. And the other one is 8/5. Look at the numerators of those zeros. If you multiply them together, what do you get? Which is the constant term.
Way.
Look at the denominators of those two things. If you multiply them together, you get the leading coefficient.
What? No way.
Okay? It works for... I do enjoy the feigned enthusiasm. It even works for higher degree polynomials. So we got a cubic here. It factors to these three. What are the zeros? 3/2, 7/5, -11. I'm going to write it as -11/1. Okay? If you multiply the numerators, what do you get?
231.
You get 231. It's going to be the constant term. All right? It will be, but I don't care about the sign because we always do plus or minus. So 3 times 5 times -11 gives you 231. That's just a positive. I don't care. And what about the denominators? 2 times 5 times 1 is equal to 10, which is the leading coefficient.
Isn't that 3 multiplied by 7? Yeah. Man, you got wrong.
Just testing to make sure you're paying attention.
When you need that,
I'll look to the Italian. All right. This is called, you ready for it? The rational zero theorem. Okay? What does rational mean? I told you yesterday. If you see the word rational, what do you know? Fractions. It is a fraction, right? Because it's p/q. So to get the possible factors, what you do is you take all the factors of the constant term. That's what we did yesterday. And you divide by all the factors of the leading coefficient. Yesterday, our leading coefficient was 1. So that's why we didn't really worry about that part. But today, it's not going to be 1. Okay? They call it p/q. I don't care what letters you use, but it's basically the factors of the constant term divided by the factors of the leading coefficient. That's the only difference that we're doing today. So, if we have a polynomial like this, 5x cubed minus 51x squared, 55x minus 9. You figure out all the factors of the constant term. 9 plus minus 1 plus minus 3 plus minus 9. Okay? Figure out all the factors of the leading coefficient, which is 5. Plus minus 1 plus minus 5. They go over top of one another. You're dividing it. So to get the possible factors, what you have to do is you have to go 1 divided by 1 is 1. 1 divided by 5 is a fifth. Then you go 3 divided by 1 is 3. 3 divided by 5 is 3/5. 9/1, 9. 9/5, 9/5. That's how you get the potential zeros. All right? So if I now say, what are the potential factors? What do I do? When I say factors, what am I asking for? You're asking for brackets, right? So we go x plus minus 1, x plus minus 3, x plus minus 9, x plus minus a fifth, x plus minus 3/5, x plus minus 9/5. Now, they want it written in the form ax minus b, i.e., they don't want any fractions. So what 3 do I need to change, and what do I change them to? So the 1/5, this one needs to change to 5x plus 1. What does the 3/5 change to? 5x plus 3, or plus minus 3, I guess. And the 9/5 changes to, those give you the same a values. Okay? You always, they will, and I will ask for this, I always will want the factored form written in with integral coefficients, i.e. no fractions. Okay? All right, we're going to factor this. So, show that x is equal to 1. And again, on a test, I'll ask you to list them all, and then I'll narrow it down to 3, and you just have to figure out which one of those 3 work. How do you know if it's a factor? If the remainder equals 0, exactly. So they're telling us, show that x equals 1 is a 0. If I say x is equal to 1, what's my a value? It's 1. This is your a value. Okay? So we're going to do division on this thing. 1. Do I have to put in any placeholders? Nope. We're all experts at this now? Okay, go. I'm freezing it. We'll see if we match up. And then write it as dq plus r, please. What? Does equal 0. So you rewrite it as x minus 1, 5x squared minus 46 plus 9. How do I factor 5x squared minus 46 plus 9? Decomp, or whatever method you, I don't care which method you use. Yeah, so we go 5 times 9 is 45. What multiplies 45 and adds to negative 46? Negative 45 and negative 1. You were close. So I rewrite the middle term. You bracket the first two, take out a common factor, take out a negative 1 of the second two. So this whole thing factors to x minus 1, 5x minus 1, x minus 9. Yeah.
Can you use the same theorem to solve for x quadratic function?
To factor a quadratic? Yeah. But it's easier to just factor a quadratic using our known methods, because you'd probably get a bunch of factors of 9. You'd have to test them, right? So It's easier just to do it the way we've been doing it. But yeah, theoretically, yes, you could, because this applies to any polynomial.
Okay.
But we just use it for the higher degree ones because we don't have a formula for those. If I ask you to solve this equation, what am I asking for? Solve for 0. So what makes each bracket 0? So x is equal to 1, 1/5, and 9.
What about 3 and 5?
What?
Like 3/5 or something? This 3 is also a factor of 9.
No. It's the whole polynomial. Like this and this are the same thing, right?
Okay.
So now I've written in factored form. If I set that equal to 0, which is this, I just have to make each bracket 0. Okay. Is that okay? Same stuff we did yesterday. The only difference is this P over Q thing up at the top here, where you have to divide factors of the constant term by factors of the leading coefficient to get all the possible factors. I will narrow it down for you, and then you just do the same stuff we did yesterday. Is that okay? All right, here's what you're doing. Numero. Why did I do 1? Number 2, use x plus 2. Number 4, 3x plus 1 and x minus 1. And number 5a and 6. And there's your, I give you the A value type things that I need you to use.
Oh, I think this is about.
This lesson's over. We're going to start graphing today. Are we not excited?